My name is Thorsten Lorenz. I work for NodeSource, and lately I have had the opportunity to look into V8 a little closer because we wanted to understand a little more what's going on there, specifically how it relates to performance. And a lot of people actually do benchmarks, right? They're trying to figure out, is this faster or is that faster? But if anyone saw Slava's talk last year, Alex.js, basically he teaches you that the compiler is smarter than the table, and he basically trashes your benchmarks. Then you kind of realize that maybe benchmarks are not the best solution. And actually yesterday, had something with Mikola. We're trying to figure out why it takes so long to create a float array around a array buffer, and he had a benchmark going on. And he knew it was slow, but we had no idea why. And that doesn't really help me that much. And after we actually created some flame graphs and looked at V8 code, debugged through it, we actually realized that it's a garbage collector that's actually collecting stuff after a while after you create a bunch of those. So in my opinion, benchmarks may be useful, but it's way more important to understand how things actually work. Like, how does V8 actually deal with your code? Like, how does it represent your data and your types and so on? And then you can basically go and kind of write your code in a way that makes V8 happy or allows it to optimize it better. And one thing to understand here is whatever I'm going to tell you applies to mostly to code that runs a lot, right? You don't want to write your code to be optimizable all the time. You want to write it for like the hot code path. And also, since this is a front-end talk, I have to find an excuse why I'm here. So this obviously applies to Chrome, what I'm going to tell you. Obviously applies to Node. Also applies to other browsers, though, because the concepts are kind of similar. So whatever kind of is good for V8 usually also is good for, like, say, Firefox or that Explorer thing. So I try to, I have a repo up there that has a bunch of data about this, and I try to pick the most important things so I can put it into a 20-minute talk. So I believe that one thing to understand are data types, like how does V8 represent your objects or numbers or whatever under the hood. And the other thing is to understand a little bit how the V8 compiler works and how it optimizes the code. So these are basically the two main things that I'm going to talk about. So one thing to first understand is that there's there are the ECMA types, right? And then there are also the types that actually V8 uses under the hood. So they are not exactly the same. So ECMA defines primitive types and defines reference types. And if you start, for instance, looking at the number, ECMA defines this number as like a 64-bit. And V8, though, decided to pass everything around as a 32-bit value. Like, it doesn't worry about larger things. And so how do you even match that up, right? Obviously, you can't put a 64-bit number into a 32-bit slot. So we have to talk about tagging at that point. And so one, if you think about it, okay, so 32-bit, right? I could put 32-bit integers in there. They're called small integers. So that fits in there. And if it's not, then I put a pointer, right? I can put a pointer there, 32-bit, that points to like the object or the 64-bit number. But the thing is now, like, when V8 reaches that memory, like, how does it know if it's actually a number like that it can just use, or is it a pointer? It hasn't, you have to kind of tell it. So using 32-bit values doesn't really work. What you actually have to do is 31-bit numbers, right? So you get 31 bits for your small integer, and then that extra bit can be used to tag it, like, meaning like the 0, you can think of it, it means like there are 0 hops, right? It doesn't have to go anywhere else to get the actual value that's in here. It can just take that value as is. And if you have an object pointer, then you basically put 1 there in that 1 bit. That basically tells it that, okay, I have to actually dereference that pointer and find the object somewhere else. And that's also how it can represent doubles, which don't fit here. It can actually box them and treat them kind of like objects and store them somewhere else, but basically pass around the pointer. But obviously, if you want to save that hop, right, you want to use small integers as much as you can because that makes you a little bit faster. So now let's look at objects. So objects basically all have a map. And we're going to get into all these things I'm going to get into detail. But a map basically is like a representation of your object. It tells, it stores everything about the structure of your object, and that's important, as we will see later. And then we kind of skip to a few slots here, and every slot is 4 bytes, like 32-bit. And then the properties are here. So the first property is at offset 12. And you can have more than one property. Those are like the fast properties that are stored inside your object. Right? But some properties just don't fit in that object, and those are stored somewhere else. They're stored in a fixed array outside of your actual object. And then there's an extra properties field that basically points to that fixed array. And then we have special properties, which are like 0, 1, anything that's numeric. And that gets basically stored in the elements object. So in another fixed array where all these elements go. And let's talk about that a little bit. Like every property, basically every key gets stringified. Like if you pass it an object, it gets stringified. There is no key that's not a string. If you give it a number like 1, it will stringify that 1. So it's just basically like, you can think of it as like a hash table with strings as keys. But the thing is that if you have any numbers, they get treated different, and they then basically arrays are just objects, right? Which have the keys are just numbers, and then it has this magic length property that basically gets updated every time you add a key to the object. And now we're going to talk about some of these things in detail. So let's talk about the map first. The map is really, really important. So the map basically stores all the information about your object. About the object structure. Like, think of it as like the blueprint of your type. So it stores information about where the properties are, right? Because what it wants to do, it wants to be able to kind of be faster than treating it as a hash table. It wants to say, okay, you're asking for property foo, and it's offset 12, so I know where my object starts, so I can just basically jump there and like read that memory, and now I'm reading the property. That's way faster than having to go through all the properties and find property foo and then read that, right? So the map also stores information about the size of your object. It stores information about your prototype and your constructor and so on. And if you have any object that uses the same constructor and the properties are added in the same order and it's the same properties, they will have the exact same map, and that's important. So let's look at the map here in a little more detail. So let's say you created a point, right? And you kind of wrote this first line, but the things we're thinking about like execution, right? Like not the actual code, like say you said new point, and now it executed this first line. And now V8 under the hood creates a map for that object. Basically like thinking about the structure of that object. It knows now there's a constructor, it knows it has a prototype, so it creates that, map 0. And now we're adding a property to it, x. So what it does now, it creates another map that basically says, okay, this is a map of an object that's kind of started with map 0, but now it actually has a property x, and property x is at offset 12, and that's for the fast access, right? And then also what it does, it will add a transition to map 0, meaning that if you're using an object with map 0, but now you're seeing someone add a property x to it, start using actually map 1, but you don't have to, so that's basically for reusing maps, right? So you can just transition to map 1, and by the way, property x is at offset 12. Now if you add another property, it's kind of the same story, right? Now it creates map 2, and it basically tells map 1 to transition to map 2 whenever we add property y, right? So, and when you finally finish this, the constructor, it will actually create the hidden class and use that now to represent your object, right? So that's basically, that's the main reason to understand here that V8 is really trying to help you make your code fast. And the way to do this is like to basically create under the hood representations that are kind of like statically typed in a way. So it can basically do all this offsetting when it's trying to access data of your objects, right? Because the hash table is kind of slow. So it tries to not use a hash table as much as possible, right? So now let's look at the extra properties real quick. So the extra properties, basically how this works is like you create an object, like say our point, right? And initially when it sees the first new point, it will basically say, okay, you get 32 slots for your properties. That's just the default. It will create an object of the size that will hold 32 properties. But then it will collect information about the other point that you create. And after you created about 8, the second magic number, it will basically look at all the points that you created, and it will look at find the largest one. And then it will assume that, like probably the next points that you're going to create are not going to be any larger than that. So for any future points you create, I will actually give you that size. Instead of for 32 properties, you get maybe only for 2 properties. And all the properties that were already created before, they now basically get downsized to that size. But now you may be confusing V8, and like now, for in the future, you actually add more properties to a point, and now obviously it can't store that in this object anymore because it's too small. So that's when it uses the extra properties field and stores them basically in an external fixed array. And the elements field is a little different, but basically it's for these numbered properties, right? That they get stored somewhere else. And the interesting thing there is that if you add different, if you have different number of elements in there, it can still use the same object map. Like, so basically your object structure itself didn't change. You just added more elements over here in that fixed array. So it can optimize the object, even though maybe the elements are different. It can still use the same object structure. And vice versa, it can also use the same structure for the fixed array. Right, so you can see, I have a sip of water here, but you can basically see that V8 is really trying hard. I mean, really hard. So if you create a point and then you maybe assign Z later on, it creates another map for you. If you assign them in a different order, it will try to do that too, and it will create a bunch of maps for you, and so on. But at some point, it's just like, okay, guys, like, I can't help you, my friend. You're creating just like too many weird things. Like your code is totally unstructured. I don't know what the hell you're doing. And if I would create all the maps that you make me create here, we'd probably run out of memory pretty soon. And it's actually more efficient now to actually just use hash tables. So sorry, no structure for you, hash table. And that's way slower. You don't want that to happen. You kind of want to avoid that for code that you want to run fast, right? And so use a hash table for different objects, for difficult objects. And again, it's very much slower to access a property in a hash table, right? Because it has to go through all the properties and find it. So basically, a hash table is nothing but an array, in a way, right? Where basically every key has a slot, and it will just find it there. But if it can offset, that's like so much faster. So you want that. And so that brings us to the next topic, which are arrays. And I'm going to show the typed array first, because that's basically what you want to use anyways. So typed arrays are arrays where you basically tell it firsthand that I'm going to use like a float 64 array, so all my elements are going to be 64 bits long. And what it does then, it basically uses an unboxed backing store, and pretty much that's just a fancy word for saying I'm not going to put the double somewhere else, I'm just going to store the doubles right there. But in order to do that, every slot has to be 64 bits, right? But now if you think about that, if every slot is 64 bits, and I'm telling it I want the 10th element, right? It can just start at 0 and go to 640, and that's where my element is. So I don't have to traverse through the array in order to find that element. So, and basically that's what you would want. So it's a linear buffer, and if you're saying I want to float 64, you're pretty much like locking yourself in for that. But even for like normal arrays, V8 does the same thing. So if you create a normal array and you don't screw with it too much, it will actually also represent it as a linear buffer, right? But now if you put mixed values in there that have different length, you're again confusing V8, like, and it's always going to try to make you happy. So You put ints in there, it will use 32 bits elements. And now suddenly you put a double in there. It's like, okay, throw everything away, make 64-bit slots, put the integers back in. You're creating a bunch of work. So don't put mixed types in arrays if you can avoid it. Right, so basically, like, you usually put like small integers in an array, or you put doubles in an array, and again, just make sure that V8 can use offsets. That's like the main thing here. There are certain requirements that you have to fulfill to make your array like representable in the linear buffer. So you cannot have like sparse arrays, and we get to that in a second. Why that's bad for V8? It has to be zero-based. So that's better. So the offsetting can work. Kind of has to start at 0, and don't allocate larger than 100K elements, and that's a constant in the V8 code actually. Because if you do that, basically what V8 has to do is basically like, okay, you're creating 200K elements here, and each is 64 bits or something. So you're telling me that you want this huge thing, and then maybe you only use 3 elements of that. I'm not going to do that because I'm probably going to run out of memory. So you first have to prove to me that you're actually using this much. So what you do not want to do is create a new array of like more than a million elements or whatever, right? Because then basically V8 will just say, okay, here's your dictionary. Like, like I'm just going to treat this as a hash table. What you want to do though is, if you really need that many elements, just create an array and then grow it. Because now while you're growing it, V8 knows you're actually using that much space, so it makes sense for you to use a buffer for that. Right? The other thing you don't want to do is you don't want to pre-allocate an array at a certain size and then use more elements than you allocated. Because now you basically make V8 create this linear buffer, and then you use more stuff, more space, and then basically has to throw that away and has to do all kinds of work. So if you want that, just like admit that you don't know the size yet, and just create an array without a size, and then V8 will grow it over time, and we'll try in the future to represent it as a linear buffer. Don't do that. That's bad, because you're destroying the object structure that V8 created for you. Right? You're deleting a property that's confusing the hell out of it, and it's just going to say, okay, no structure for you, my friend. You're going to be using a hash table and be slow. Don't do that either. If you need mixed properties, at least tell V8 right away, right? Like basically allocate your array with the different types in there, instead of like starting with an integer and then it's going to optimize for integers, and then later on you add a double and then has to throw this away again and whatever. You're creating a bunch of extra work for V8. You don't want that. But in general, just don't use mixed arrays. I don't really see a case where you really need them. So now I have a really small time, but we're going to go race through the compilers real quick. So the compilers, basically there are two compilers. One is the full compiler, and the full compiler is a very fast compiler. It just compiles immediately. It generates some JavaScript that's not optimized at all, but it's so you can start running your code, right? And then while your code is running, it will actually watch you using your code. So it will watch your functions, and it will watch like what types are actually passing into these functions, so that it can use that information later to optimize. So the optimizing compiler, basically what it does, it keeps a track of how many times also you execute a function, and at some point it's going to realize, okay, this function is kind of hot, I should probably optimize that. And then it uses information I collected about the types you're passing in to generate basically assembly code for you that basically matches that function. Right, so basically it's basically recompiled in a more efficient manner, making certain assumptions. And that's important, like that it basically makes assumptions. So the inline caches are basically gathering knowledge, right, about you, like about how you're calling your function. And then it generates type-dependent code, meaning like this code will only work if actually the assumptions you make about your types will always be true in the future. And that alone, like this type-dependent code already makes you like 20 times faster. But then once it basically collected enough, it will create assembly that's super fast. But every time it runs an assembly, it will first compare the maps of your inputs, right? So if it assumes like I'm only getting these kind of objects. If the maps don't match, it will basically bail out, and the meaning like it de-optimizes the code. So like if the speculations are not met, it will have to bail out. The optimizer code basically have to start over. And then it keeps watching your execution again for a while, collect more information, and then we'll try again to optimize your code. And that's totally normal, right? That can happen, that's fine. But again, if you do it over and over and over, and for instance, that's like the case for nested functions, where it basically always throws away the function and it keeps optimizing it, and at some point it's just going to say like, okay, guy, I'm not going to optimize this function anymore because it obviously doesn't make any sense. So it just like says, okay, you go to optimization hell. You'll never get out of it again. And that's very important to realize because V8 was written for the browser, right? So they were not thinking of you running a server for days, possibly, right? And now if you in your server, a function ever gets marked as not optimizable, it will never, ever, ever, ever be optimized again. It's not going to be like, oh, it has been like 3 days, maybe I should try again. It's not going to do that. It's a very simple algorithm made for the browser, right? So keep that in mind. Oh, and one more thing. Certain constructs inside of your function, they just make it go to the optimization hell right away. Like if you have it in V8, the newest V8 I learned yesterday has actually fixed that, but if you have a try-catch somewhere, that function will not be optimized because V8 supposedly couldn't figure out how to optimize it. So don't put like computation-intensive code right in a try-catch block. What you could do though is you create a function inside the, you call a function in the try-catch block, and then it's over here, and that function now can be optimized, right? It just don't inline the code in there. And then another one is for in that cannot be optimized for whatever reason. So there are a bunch of those that you have to watch out for. So real quick, we're going to go through here an example. We have a point, right? We created this point, and we call this function with this type of point, which has properties x and y, like a gazillion times. Now that function gets optimized for the point with x and y, and later on, suddenly you add a property z to that point, and you call the same function again. Now basically the function has to be de-optimized, right? Because now that's a different structure. You added a property, so now it has to basically start over with optimizing all the functions that were using the point, because they have been optimized only for x and y. So what you want to do is make sure to initialize all members in your constructor in the same order. And even if you think that a lot of times you may need a property, but it's not assigned all the time, assign it anyways. Assign it to undefined, just to teach V8 that it will have that property. And actually, if you look at the event emitter code in Node, you will see that they're actually assigning a bunch of undefined properties, and they do that in order to kind of already tell V8 about the object structure and keep it constant. And then you want to avoid polymorphic functions. Polymorphic functions are basically functions that take different types, where you kind of say, if the second argument opt is actually a function, then that's actually my callback and blah, blah, blah. That's kind of cool, but it really confuses V8. What you should do is then put your code somewhere else that actually does the work and do all this like figuring out in that function and make that call that other function, right? Right, and don't do any work. Yeah, basically, you don't want it to work in a function where you know it's not going to be optimized easily. So again, there's way more stuff to this. This is kind of like a peek preview of what's in this repo here. So if you're really interested in all the details, I tried to collect everything I found on the internet, and as much as I found so far in here, and I linked all the resources that I found. So I kind of want this to grow, and hopefully some of you can help if you find more stuff. Create an issue or a pull request. I want this to kind of, it's not very easy to find all these resources. So I want to kind of make this easier in the future. So create this repo. Help out. And there's it. Thank you.